These are integrated circuits, often abbreviated as an IC. Integrated circuits are electronic components that contain many tiny electronic circuits inside of a single chip. Rather than building an entire circuit from dozens or even hundreds of individual components, engineers can place many of those components into a single chip. By connecting many transistors together inside of the chips, engineers can create circuits that make decisions and process information. This brings us to Boolean logic. Unlike traditional math that deals with different numbers, Boolean logic works in two separate states, true or false. In electronics, these states are represented by voltage levels. A low voltage typically represents as digital 0. A higher voltage is represented as a logic 1. Using only these two states, electronic circuits can perform digital logic operations and make decisions. In electronics, these decisions are performed by circuits called logic gates. A logic gate receives one or more inputs and produces an output according to a specific logical rule. You can think of a logic gate as a tiny decision-making circuit. The output depends entirely on the state of the inputs. These specific logic gates included in this kit are represented by the serial number on the integrated circuit. The logic gates included are the following: 7400, which are NAND gates, 7402, which are NOR gates, 7404, which are NOT gates, or also called inverters, 7408, which are AND gates, and finally 7432, which are also called OR gates. Each of these chips perform a different logical operation. For example, an AND gate only produces a logic 1 when all of its inputs are logic 1. An OR gate produces a logic 1 output when any of its input are logic 1. A NOT gate simply reverses the input state, or inverts it. The NAND and NOR gate are variations of these operations that produce the opposite result. One interesting fact is that all digital electronics can ultimately be built from combinations of logic gates. Every computer operation is built from logic gates, even how you're watching this video right now. If we look at the integrated circuit itself, you'll notice a notch or dot on one of the ends. This indicates the orientation of the chip. Every pin on an integrated circuit has a specific purpose, and the pin numbering begins at the end with the notch or dot and continues around the chip as shown in this diagram. The internals are slightly different depending on what type of logic gate you're using, but this diagram shows the internals of a NAND gate. To find the internal diagram, simply look up the serial number, for example 7400. Because every pin serves a different function, it's important to install integrated circuits in the correct orientation. If you look at breadboards, they have a center gap, which makes it easy to install integrated circuits across the center gap. The chip sits perfectly in the gap, giving you access to every single pin, while also preventing them from accidentally connecting together. As you continue through these lessons, you'll learn how each logic gate works and how to use the chips to build increasingly complex circuits. These same fundamental ideas form basic computers and many of the electronic devices we use every day. For now, just remember that integrated circuits contain many electronic components. And the ones included in your kit are Boolean logic, which make decisions based on the electrical signals. Thanks for watching, and I'll see you in the next lesson.